Hello everyone, welcome to another Wave to Wave webinar and thank you for joining us today. We invite you to review our entire webinar lineup for a full appreciation of the beneficial impacts of robotic fiber switching in various layer 0 deployment scenarios. The use of fiber optic cable throughout data centers has taken off in recent years as a result of moving to higher densities to satisfy traffic growth and services demands. Organizations that once considered 1 gigabit Ethernet or 10 gig E sufficient bandwidths are being driven to deploy 40, 100, and even 200 gig E and beyond. The truth of the matter is fiber optics is the best medium to support those speeds. Fiber also provides longer runs than copper with lighter cable weights, resistance to electromagnetic interference, as well as promoting better data center security. Although capacity, speed, and reliability are critical to data centers, architectures must also be sufficiently robust and manageable to carry ever-increasing traffic volumes while also enabling increases in data center densities. Today, we will focus on the emergence of all fiber data centers and its ecosystem components. Next slide, please. We will highlight in this session key ecosystem components impacting data centers. We'll start with an overview of growth drivers and data center traffic dynamics. We will then look at trends in fiber deployments within data centers, followed by a discussion on the emergence of silicon photonics technology and its impacts on data center architectures. This includes a summary view on the all-fiber data center leaf spine or fat tree designs, specifically zeroing in on pod deployment impacts. We will also present an optimum testing architecture for an all-fiber data center and highlight synergies with emerging economical DWDM appliances. We will close with demonstrating that seamlessly integrating robotic fiber switching with other ecosystem components significantly reduce service delivery times. So let's get started. Next slide, please. Cisco released its annual Global Cloud Index and indicates both consumer and business applications are contributing to the growing dominance of cloud services over the internet. The study forecasts global cloud data center traffic to reach 20.6 zettabytes per year by 2021, up from 6.8 zettabytes per year in 2016. A zettabyte is a billion terabytes, in case you were wondering. Globally, cloud data center traffic will represent 95% of total data center traffic by 2021, compared to 88% in 2016. Driven by surging cloud applications, data center traffic is growing fast. The Global Cloud Index also highlights the fact that the cloud is moving well beyond a regional trend to becoming a mainstream solution globally, with cloud IP traffic increasing by a factor of 3.3 over the next 5 years, as shown. Data center application growth is clearly exploding in this new multi-cloud world. This projected growth will require new innovations, especially in the areas of public, private, and hybrid clouds. Bandwidth demands will continue to change data center network architectures, as the majority of server port bandwidth currently operates at 10 gig E, but is moving to 25 gig E and 40 gig E. This increase in demand at the server level is driving the need for 100 gig E switch connectivity. Therefore, data center build-outs will continue to grow, driven by the increase in bandwidth demands and changes in network architectures. Next slide, please. Turning our attention to data center traffic dynamics, traffic residing within the data center accounts for 75.4% of data center traffic in 2016 and will be 71.5% by 2021. Note, this does not include rack local traffic, which is traffic that remains within a given server rack. Overall, east-west traffic, which is the sum of traffic within data centers and between data centers, will represent 85% of the total data center traffic by 2021. North-south traffic, which is traffic exiting the data center to the internet or WAN, will be about 15% of total traffic by 2021. Networks and data centers worldwide are growing to accommodate the digital economy. As online transactions proliferate and companies leverage the Internet of Things to automate the monitoring and management of physical assets, data streams are exploding in size. New network architectures are targeting throughputs of 40 gig, 100 gig and higher, and cabling systems must incorporate advanced designs to support these massive throughputs. While expansion can be accommodated by adding new servers and storage, it is also met by deploying adequate layer 0 infrastructures to allow more bandwidth. As data rates increase, the use of fiber optic cabling in the data center is becoming more commonplace. Advances in optical technology make fiber more affordable, more practical, and easier to use in the data center. Next slide, please. A fundamental new trend that is transforming the data center is software-defined networks, or SDNs, and network function virtualization, or NFV. SDN, programmable optical networking, enables the layer 0 optical infrastructure to coexist with packet switches under centralized management control for efficiently orchestrating topology changes. Even horizontal cabling within the data center is increasingly fiber optic. Organizations that once considered 1 gig or 10 gig sufficient bandwidths are being driven to deploy 40 gig, 100 gig, 200 gig, and beyond. Capacity, speed, and reliability are critical to the market, and new optical layer 0 cable plants are being constructed for a number of applications, including mobile and data center cloud operators. These networks must be sufficiently robust and manageable to carry higher volumes and enable increases in data center density. By building sound layer 0 infrastructures that support flexible resource allocation, businesses transform and scale continuously with greater agility. As part of this ecosystem, other technologies are also emerging to support fiber deployments within data centers. Next slide, please. An example of optical technology disruption is silicon photonics. Developments are underway to move switching functions into the optical domain to relax the need for digital functionality in CMOS and vastly increase spine and leaf switch node throughputs. This new technology will alter how data center systems exchange data and make rack equipment leaner by reducing total cost of ownership and removing networking bottlenecks that can result in stranded compute capacity. Silicon photonics is widely accepted as a key technology in next-generation systems and data interconnects. It brings the advantages of both semiconductor integration and photonics, where high levels of integration can be achieved with low manufacturing costs by using a conventional silicon integrated circuit infrastructure. Therefore, silicon photonics is changing the rules of data center IT equipment and associated equipment requirements. Specifically, data center architectures can be made significantly more efficient and scalable by bringing silicon photonics to switching nodes. Data center engineers and architects are planning for large-scale deployment of silicon photonic-based switching appliances in upcoming hardware replacement cycles. The general market assumptions are that silicon photonic interconnects costs will drop to $1 per gigabit per second due to high-density integration in WDM. Next slide, please. High-density integration of silicon photonics with spine and leaf switching electronics enable a dramatic increase in the bandwidth per fiber and scalability. As this architecture is deployed in data centers, fiber counts multiply very quickly when compared with traditional three-layer distribution architectures. The increased east-west data traffic has also created long cable runs in large facilities. For spine and leaf architectures, each leaf switch in the network connects using a mesh to every spine switch in the network to provide increased resiliency. The only sure way to manage the exponential growth in fiber counts, then, is by using an automated fiber cross-connect, shown here, inserted as an ecosystem component of a data center pod within the deployment architecture, creating a FlexiPod deployment approach. As part of the all-fiber data center ecosystem, advanced robotic optical cross-connects are indispensable components, even when utilized as part of the end-to-end service delivery process, which includes operations, administration, maintenance, provisioning, and testing. Next slide, please. Speed is a concern for data centers, but so are reliability and availability. Data centers must be available 24/7, 365. Reliability comes from designing devices with redundancy, while availability comes from having automated testing processes that quickly isolate and report on network issues. This diagram illustrates a process flow for testing that utilize the all-fiber data center key ecosystem components of a robotic optical fiber switch, an automated optical test equipment, and a DWDM appliance. Let's assume the NOC reported a traffic failure between a server and a switch port. Upon notification, the Roam fiber switch can be pre-programmed to automatically disconnect the server-side interface on the left unit and switch-side interface on the right unit. Roam then connects the test port to the DWDM problem channel on both units. The test signal is then automatically generated and measured by the test equipment, such as a bit error rate test over the DWDM channel. If there is a channel problem, Roam can switch the server side to a predetermined protection port, and the DWDM channel card can then be replaced. This setup also assists technicians in troubleshooting by quickly isolating the problem to interface ports on either the switch or server. In addition to test process optimization, these two key ecosystem components can also partner in other areas, such as maximizing data center network utilization. Next slide, please. Incorporating an automated optical cross-connect enables the instant delivery and provisioning of any-to-any physical connections. Automation provides the ability to virtualize these connections via software. An automated connectivity fabric makes data center layer 0 networks dynamically reconfigurable with security, speed, and accuracy that traditional manual processes just cannot match. By inserting Wave2Wave's Roam robotic automated optical cross-connect products into next-generation data center architectures, operators can significantly reduce service delivery times. The resulting order of magnitude provisioning time gains can translate into both faster time to revenue and high customer satisfaction. So the data center of the future has the potential of not only lowering operations and capital costs, but also dramatically improving services delivery speeds while simultaneously reducing the complexities of operation, administration, maintenance, and provisioning. So in summary, traditional data center multi-tier switching architectures have limited scalability and cannot keep up with growing internal data center traffic and connectivity demands. Data center IP traffic will experience 3x growth over the next 3 years. Standard traditional switches alone cannot economically or physically scale to meet projected data center requirements. Data centers need scale, so the use of optical fiber solutions is ideal to position data centers for tomorrow's needs. Incorporating an automated optical cross-connect enables the instant delivery and provisioning of any-to-any physical fiber optic connections, and automation provides the ability to virtualize these connections via software. Adoption of network architectures such as spine and leaf are driving the scale of fiber cabling infrastructure requiring greater fiber counts. As this architecture is deployed in data centers, fiber counts multiply very quickly when compared with traditional 3-layer switching architectures. Technology trajectories need changing, and new ecosystem components are providing the change. An automated connectivity fabric makes data center layer 0 networks dynamically reconfigurable. This on-demand connectivity of silicon photonics-based switching products opens the door to a broad range of new applications within the data center ecosystem, including FlexPod designs. So in closing, we want to thank you for joining us today and look forward to seeing you on another Wave2Wave webinar in our series. And please, feel free to send any questions you may have to info@wave2wave.com. Have a great day and see you soon.